In this video, we'll provide an overview of the RETScreen energy model. First, we'll explain the capabilities of the model. Second, we'll discuss how RETScreen uses the various parameters to calculate energy that can be produced by a wind energy project. And finally, we'll show how RETScreen has been validated against other models and actual field data.
RETScreen Wind Energy Project Model. The RETScreen Wind Energy Project Model is a simple but very useful tool for a preliminary investigation of technical and financial feasibility of wind energy projects. For an installation anywhere in the world, it can provide an analysis of the energy production, life cycle costs, and greenhouse gas emissions reductions. The installation can be connected to either the central grid or an isolated grid, a single turbine, or a wind farm. At present, standalone turbines requiring battery storage are not covered by RETScreen. To conduct this analysis, the user provides information about the wind speed distribution at the site. If the user has very little information about the wind resource, a typical wind speed distribution, known as the relay distribution, can be assumed, and the user needs to provide only an estimate of the annual average wind speed. If the user knows the shape of this wind distribution, this can be specified in terms of an additional shape parameter for the so-called Weibull distribution. If the user knows that the distribution is not modeled by the Weibull, he or she is free to enter a turbine energy curve corresponding to an arbitrary distribution. In this way, the user can have highly accurate estimates of annual energy production based on as little data as the average wind speed, while not being limited to typical distributions. The RETScreen wind energy calculation. As mentioned in the previous slide, RETScreen permits the user to specify the wind speed distribution that characterizes the site. When the user selects a relay or Weibull wind speed distribution, this fixes the shape of the distribution for a given average wind speed. This is the starting point for RETScreen's calculations in the energy model section of the software. First, RETScreen combines the wind speed distribution with the power curve of the user-selected turbine to generate an energy curve giving the turbine's annual production as a function of average wind speed. RETScreen includes a database of power curves for many different turbines, which relate the power output of a turbine to the wind speed. Second, RETScreen determines the annual unadjusted energy production by locating the point on the turbine energy curve corresponding to the average wind speed specified by the user. This gives the unadjusted energy production for a single turbine. RETScreen multiplies this by the number of turbines in the installation. Third, RETScreen adjusts this energy production estimate to account for the average density of the air at the site. This is found from the annual average air temperature and barometric pressure, both contained in RETScreen's weather database. The result is the gross energy production for the site. Fourth, RETScreen revises the estimate of the gross energy production to account for losses due to the turbines being located in the wakes of other turbines, airfoil soiling, airfoil icing losses, and expected downtime. The result is an estimate of the energy collected by the turbines. Fifth, RETScreen compares the energy collected by the turbines to the energy that can be absorbed by an isolated grid. If the turbines produce more than can be absorbed, the energy delivered will be less than the energy collected. In central grid systems, the energy delivered is the same as the energy collected. Finally, RETScreen calculates the values of various auxiliary quantities, such as the specific yield, the wind plant capacity factor, and the excess renewable energy available. Example validation of the RETScreen Wind Energy Project Model. The RETScreen software has been validated in a number of ways. For example, RETScreen has been compared with the National Renewable Energy Laboratory's Homer simulation tool, which uses hourly wind speed data. In particular, for an installation consisting of 10 turbines of 50 kilowatts each, located on the isolated grid of Kotzebue, Alaska, RETScreen and Homer agreed to within 1.1% in their estimates of the annual energy production. RETScreen's prediction of the annual energy production for this installation was compared with monitor data from the installation. Over the years of 1998 through 2000, RETScreen underestimated the actual energy production by only 8 to 10%. This is sufficiently accurate for pre-feasibility purposes.
Thank you for watching this video. In the next tutorial, we will demonstrate RETScreen through a small wind project in Europe.